There's a place in the universe where the laws of physics simply stop working, where time slows down, where light can't escape, and where, according to some physicists, your body would be stretched like a strand of spaghetti before you even realize what's happening. And here's the unsettling part. A black hole like this exists just a few steps away, in cosmic terms, from Earth. It's watching you right now, silently, from thousands of light years away. Today you're going to find out what would really happen if you fell into one. A black hole isn't a hole, and it isn't black in the way you might imagine. It's what remains when an extremely massive star dies. It collapses under its own weight, and all that mass, sometimes dozens of times heavier than the sun, gets compressed into a space smaller than a city. The result is gravity so extreme that not even light can escape it. That's why it appears black, not because there's nothing there, but because no information can get out. But here's the problem. Scientists discovered that the math behind this predicts something so strange that Einstein himself refused to believe it was real. And decades later, it was proven that he was wrong. Every black hole has an invisible boundary called the event horizon. Think of it as a line in space. Outside of it, you can still escape, still fire up the engines and run. Inside it, there's no more running, because once you're past the event horizon, every possible path leads to the center of the black hole. It's not a question of having enough force. It's a matter of the geometry of space-time itself. And that means something terrifying. If you cross that line, even without noticing, it's already too late. You might not feel anything strange at the exact moment you cross it. But what comes next is where physics gets truly bizarre.
If you fell headfirst into a supermassive black hole, like the one at the center of our galaxy, for a while you wouldn't feel much different at all. But as you get closer to the center, the gravity pulling on your feet becomes much stronger than the gravity pulling on your head, because your feet are closer to the center. That difference in force stretches your body more and more until you literally become a thread. Physicists actually have a serious name for this: spaghettification. But here's the twist almost nobody tells you. In small black holes, this would happen in a fraction of a second, violently, still outside the event horizon. But in giant black holes, like Sagittarius ACA, at the center of the Milky Way, you would cross the entire event horizon still intact, without noticing anything different at all. You'd only find out you were inside a black hole once it was already impossible to turn back. Now comes the part that divided the greatest physicists of the 20th century. When something falls into a black hole, where does all the information about it go? The composition, the structure, everything that made that object unique. Physics says information can never simply vanish from the universe. But black holes seem to violate that rule, swallowing everything and leaving no trace behind. This became known as the information paradox, and it pitted Stephen Hawking against nearly the entire scientific community for decades. Hawking publicly bet that information was lost forever. Years later, he lost that bet and had to publicly admit he was wrong. What he discovered along the way changed forever what we know about black holes. Here's the detail almost nobody knows. Black holes aren't eternal. Hawking discovered that they emit an extremely faint radiation, now called Hawking radiation. And over trillions of years, this radiation causes them to slowly lose mass until they evaporate completely.
This means that, on a timescale so distant it's almost impossible to imagine, every black hole in the universe, including the biggest and oldest ones, will disappear. And when that happens, no one knows with absolute certainty what's left behind. This is what makes black holes so fascinating. They're not just extreme objects. They're the places where the rules that explain everything else in the universe simply stop making sense. And that's exactly where science learns the most. If this kind of mystery makes you curious to really understand the universe, this channel exists exactly for that. Beyond the visible, beyond what you can see, but never beyond what you can understand. Subscribe, because in the next episode, we go beyond again.